The solar system holds its breath tonight. An interstellar visitor designated 3 Ice Atlas is sweeping past Mars at a distance of just 0.19 astronomical units, roughly 28 million kilometers. Every operational Mars orbiter has been repurposed for a single mission: capture whatever secrets this object carries before Earth's view goes dark. This is no ordinary flyby. The visitor blazes with an emerald coma unlike anything in our records. Its chemistry is dominated by carbon dioxide at ratios that shatter every known comet profile. Microaccelerations nudge its path in ways that defy standard physics. Rhythmic pulses in brightness, sharp and regular, suggest something beyond random outgassing. Is this a bizarre natural phenomenon, or are we witnessing something engineered? The clock is ticking. Earth's instruments are about to lose line of sight, leaving only a handful of Mars probes between us and the answer. 6 hours. That is the window before the sun blocks Earth's view entirely. Mars becomes the solar system's only observatory. Maven, Mars Express, and ExoMars Trace Gas Orbiter shift into maximum observation mode. Inside the Maven Control Center, the Red Watch crew takes command. These are operators trained for contingencies, running decision protocols for every conceivable anomaly. Backup configurations are loaded. Cross-checks with other orbiter teams are constant. Every command is logged twice. Every data packet gets a redundant copy. There is no margin for a single point of failure when the rest of the solar system is blind. The schedule is unforgiving. Mars Express captures broadband images every few minutes, stacking exposures to detect fragmentation or course changes. TGO spectrometers sweep the coma for spectral lines that should not exist. Maven's particle sensors monitor for ionospheric disturbances, anything hinting at unnatural interaction. Power and telemetry budgets are stretched to breaking. Observation slots are negotiated down to the minute. If debris threatens, Mars Express is ready to abort into safe mode, sacrificing data for survival. The abort threshold sits just 30% above the last measured density spike. The evidence file on 3 Ice Atlas grows stranger by the hour. The first hint came from Priya Raalo, a citizen astronomer in Pune, India, who spotted repeating pulses in the light curve. Professional arrays confirmed what no Comet handbook could explain. Brightness surges at nearly identical intervals, each spike arriving with sharp onset and clean decay, as if controlled by a switch. Spectroscopy deepened the mystery. Instead of water vapor, the dominant signature is carbon dioxide, with a ratio topping 8:1 against water. No known solar system comet comes close. The coma glows emerald at 516 nanometers, confirmed across multiple instruments. Nickel emission lines outshine iron by factors of 4 or more, reversing every standard comet pattern. Dust grains drift in broad, lazy arcs, released in measured bursts rather than chaotic jets. Astrometric tracking records microaccelerations that coincide with brightness pulses, linking light and motion in ways no outgassing model can explain. Planetary scientists exhausted natural explanations first. One hypothesis points to extreme cold chemistry, where carbon dioxide and carbon monoxide dominate over water ice. Another invokes volatile pockets erupting in rhythm as sunlight penetrates the crust. Dust dynamics might account for the emerald glow and large, slow grains. Some argue the anomalies simply expose gaps in our models, physics not yet captured by simulation. But none of these explanations fit all the facts at once. For 6 hours, Mars is humanity's only witness. Maven's ultraviolet spectrograph hunts for fragmentation or outbursts. Its magnetometers watch for ionospheric ripples. Mars Express images the coma, searching for splitting or shape changes. Its spectrometer scans from ultraviolet to infrared, hunting for unexpected emissions. ExoMars TGO probes for trace gases and isotopic ratios outside solar norms. On the surface, Perseverance and Zhurong rovers monitor for dust fallout or atmospheric changes. The checklist is explicit: fragmentation patterns, trajectory shifts, spectral lines that resist explanation, isotopic ratios beyond solar standards, any sign of synchronized pulses or accelerations. Every anomaly flagged by one instrument must be confirmed by another. Only converging evidence can push the verdict from unusual to unprecedented. Every byte streaming from Mars faces rigorous checks. Data packets are duplicated, time-stamped, logged by independent ground stations. Anomaly packets, those flagged for fragmentation or spectral outliers, are routed through rapid cross-verification. No single sensor can clear an alert alone. Chain of custody protocols extend to dust grains and ice fragments. Planetary protection officers enforce strict handling rules. Samples are sealed, barcoded, logged with digital hashes. The goal is clear provenance. Any organic signature found after the flyby must be traceable. Outside control rooms, amateur astronomers upload photometry and astrometry to shared databases. The first alert of spike may come from a citizen scientist, but professional teams triage uploads in real time. Extraordinary claims wait for extraordinary evidence. Inside the Red Watch control room, the decision matrix defines three possible verdicts. Conservative holds if every anomaly maps to rare but natural behavior. Hazardous applies if fragmentation or debris threatens Mars orbiters. Extraordinary demands at least two independent, statistically significant anomalies. Synchronized pulses matched by microaccelerations or spectral lines defying any chemical model, confirmed by separate teams. No single signal is enough. Only converging evidence opens the door to engineered possibilities. On October 3, 2025, as 3ICE Atlas passed Mars, over 40 hours of high-cadence data captured its emerald glow, pulse brightening, and carbon dioxide spectrum. Natural models explain much, but the pattern of microaccelerations and synchronized pulses remain without definitive cause. The raw data are now public. Key questions about the true source of emissions and whether engineered activity played any role remain unresolved. What is certain? This encounter has driven new protocols for interstellar monitoring and set a standard for transparency. Whatever 3ICE Atlas proves to be, its flyby has changed how we prepare for visitors from beyond our solar system. So what do you think? Are we looking at the most extreme natural comet ever recorded? Or did something engineered pass through our cosmic neighborhood? The data is out there, public and waiting for answers, but the mystery remains unsolved. Those synchronized pulses, those microaccelerations timed perfectly with brightness spikes, the chemistry that breaks every rule we know. Nature can be strange, but can it be this precise? Drop a comment and let me know where you stand. Team Natural Phenomenon or Team something else? And tell me where you're watching from. I want to know if this story is reaching space enthusiasts from every corner of the planet. Are you in North America, Europe, Asia, South America? Let me know down below. If you're fascinated by mysteries like this, by the questions that push science to its limits and make us wonder what else is out there, hit that subscribe button. We dive deep into the unexplained, the cutting-edge discoveries, and the moments when the universe reminds us how much we still don't know. Turn on notifications so you don't miss the next investigation. The raw data from 3ICE Atlas is being analyzed right now by teams around the world. New findings could drop any day. Do you want to be here when the next piece of the puzzle surfaces? Then stay connected. Subscribe, comment, and let's figure this out together. Thanks for watching, and I'll see you in the next one.